Okay, so what I'm gonna do now would be to solve the seat work we had this morning. So I'm trying this for the first time, so please bear with me. So what I did before I started the video was already to create a sort of some cheat sheets for the seat work. I won't be relying on the solution that I gave this morning, but we will just rely, for example, on the formulas and the figures that were given also as part of the lecture during our class discussion. So on this side, let me just, okay, this one will be of course for capacitors in parallel. And you also have here your capacitors in series. As I've said, it's very easy to solve problems like this. All you have to do is just really to understand the different combinations. So since I gave the same values for C1, C2, C3, and then for of course number one, they were connected in series, and in part two they were connected in parallel. So let's first solve the series connected capacitances. So from the example we had, so C1 is 5 nanofarad, we have C2 which is 7 nanofarad, we have C3 which is 6 nanofarad, and the voltage across that combination is 1.2 kilovolts. I won't be drawing the figure anymore, but let's just assume that we can write over this one. Let's just remove this one first. Okay, because this will be part of your quiz tomorrow. So we can use this figure already if you remember the one that was flashed on the screen. So we can say that this is 5 nanofarad, and then this is 7 nanofarad, and this is 6 nanofarad. And then across that voltage will be, we can actually write it here, that's 1.2 kilovolts. Okay, I'll just do some conversions. It's okay to retain the nanofarads, which means if you get an answer, it could probably be in farad or nanofarad. It depends on how you input it on your calculators. And then, but I have to, of course, change this. This becomes now 1200 volts. Remember, for your formula, voltage should be in volts to get the capacitance, which is in farads, and of course charges in coulombs. So those are the base or the SI units for those quantities. So first we're looking for, by the way, we're looking for C equivalent or the total capacitance of that combination. We're looking for the charges, but as you can see, for a series circuit or series combination, Q1 is equal to Q2 is equal to Q3 or equals to Q. Therefore, we can just get 1Q and it follows. Let's see later on. And then for V is different because V is summative, which means we have to individually get V1, V2, and V3. We cannot assume that V here is actually 1200 volts. It has to be solved. So V1, V2, V3 will solve them. And we're looking for energy. So for energy, we have a formula 1/2 QV. So let's use these formulas to solve this problem. So for C equivalent, okay, let's do that solution. So we have C equivalent. So we know in series combination, 1 over C equivalent is equal to 1 over C1 plus 1 over C2 plus 1 over C3. Okay, so let's just what do you call this, substitute. So that's 1 over C equivalent. You also have to understand how to use your calculators, otherwise you won't be able to get the correct answer. So that's 1 over, as I've said, you can retain the nanofarads, meaning whatever answer we're getting is going to be nanofarad. So that's 1 over 5 nanofarad plus 1 over 7 nanofarad. Okay, you can put nanofarad para hindi so that to confuse you. And then 1 over 6 nanofarad. So this is just really calculator, you have to be familiar with your calculator, otherwise we might get into a problem. So myself, let's just, okay, I'm using my calculator now because you can't see it. So let's have that. That's 1 over 5. Okay. Plus 1. Okay, let me just do that again. 1 over 5 plus 1 over 7 plus 1 over 6. So that's, and then all I have to do is get the reciprocal of that. So I'm getting, let's see, I'm getting 103. Let me just see. It's 1.96. So I'm getting C equivalent as 1.96 nanofarad. Okay. So that will be our first answer. I'm keeping that. I'm sure that that's the correct answer. You can always ask questions later after I send this or post this in the chat box. You can always ask me questions after. Okay, just do a group chat or whatever. Okay, now we have that, so we can actually get Q because we know, I'm sorry, that was a different pen. Okay, let's erase that. We can actually get Q's already here. Okay, because Q's are the same. So basically, I can get a QT. So this is already letter B. So this is letter A. For letter B, we can just use a QT, which is equal to C equivalent and VT. So my C equivalent is 1.96 nanofarad multiplied to 1,200 volts. So QT now is equal to, so when you key that in, that's 1.96 raised to negative 9. Make sure it has a negative 9 times 1,200. So I'm getting 2.35. Okay, that's 2.352 microfarad. I'm sorry, microcoulomb. Okay, my mistake there. It's microcoulomb. This is a charge. So this is now microcoulomb, or I'll just carry that over. You can actually say that QT is equal to 2.352 times 10 to the negative 6 coulombs, which is also equal to Q1, Q2, Q3. Okay, let's put a highlight to that so that you can, oh wait, how did I do it a while ago? Okay, I highlighted it. So this will be your answer for letter B. Okay, for letter C, we're using V1, V2, V3. Okay, for letter C, we need V1, V2, and V3. And from the formula, you can actually get this formula. We know that C is equal to Q over V. Therefore, V, what is V now? It's actually Q over C, right? Because Q is equal to CV. Therefore, V now is equal to Q over C. So we'll use it here. So we can get individual voltages. Okay, for example, V1 is Q1 over C, which is the capacitance, and the C's are given. So Q1, it's just 2.35 times 10 negative 6 all over C. That's 5 times 10 negative 9. Okay, V2 now is Q2 over C2, and that's 2.35 times 10 negative 6 over 7 times 10 to the negative 9. Okay, and by the way, let's do this properly. That's coulomb, that's farad, that's coulomb, that's farad. V3 now is Q3 over C3, which is again 2.35 times 10 to the negative 6 coulomb all over 6 times 10 negative 9 Farad. Okay, let's do that. Okay, just give me a moment. I'm just gonna compute them. 2.35 negative 6 over 5 negative 9. That's equal to 470. So this is now 470 volts. The other one is 2.35 raised to negative 6 over 7 raised to negative 9. So this is 335.71 volts. And I'm assuming that's 2.35 raised to negative 6 over 6 raised to negative 9. That's 391.67. Okay, volts. And just to check, if you add all of them plus 335.71, more or less they should be equal to approximately 1200 volts. It's very near. What I got is 1197.38. So these are our answers for part C. So QV1, V2, and V3. Again, it's consistent because the total voltage across that series combination is actually 1200 volts. Finally, we're gonna compute for energies. So letter D, we're getting U1, U2, and U3. We have a formula 1/2 QV, 1/2 QV, 1/2 QV. Okay, I already wrote that initially. I'm going to use that formula. So this is now 1/2 Q of the first one. It's 2.35, right? We have the same. That's 2.35 times 10 to the negative 6 times the voltage, 470. We do the same thing. 1/2 2.35 times 10 to the negative 6 times 335. Let's make that 336. It's 335.71. And the last one is 1/2 2.35 times 10 to the negative 6. 391.67. Let's make that 392. Only for discussion purposes. So that it'll be easier to key them in. But of course, for the test, you have to use exact numbers. Okay, just gonna turn on my fan. I'm just gonna make EWAS. So let's compute those. That's 1/2. Okay. So I'm getting 5.52. Okay, what I exactly got is 5.52 times 10 to the negative 4 joules. And then the other one, I'm getting 3.95 times 10 to the negative 4 joules. And the last one, I'm getting it's 4.606 times 10 to the negative 4 joules. It's okay if you can round it off to 4.61. Okay, now UT, you can actually compute for UT. UT is also 1/2 QT VT. And that is 1/2. QT is the same. That's 2.35 times 10 to the negative 6. And then VT is 1200 volts. So UT now is it's 1.41 times 10 to the negative 3 joules. Okay, and those are our answers. So that's U1, U2, U3, and this is UT. Okay, unfortunately you don't have your papers with you, but you can always go to this and review, because I might be giving the same or a similar problem tomorrow for the quiz. Okay, for now, I'll stop my recording here, and then I'll do another video for our parallel combination. Again, this is the series combination. Okay, and this is the whole solution. Thank you.